Assalamu alaikum viewers. I'm Dr. Arshad and I'll teach you mathematics. In this lecture, we'll solve exercise 1.3. The first question is, which of the following matrices are conformable for addition? We know that two matrices A and B are conformable for addition if they have the same order. That is, both matrices have the same number of rows and the same number of columns. Here, for example, if we consider the matrix A and B, here we see that A is of order 2 cross 2, 2 rows and 2 columns. So A is 2 by 2 matrix because we have 2 rows and 2 columns. Similarly, B is 2 by 1 or 2 cross 1 matrix because the matrix B has 2 rows and 1 column. In the order, first we write the number of rows and then the number of columns. In this case, we have two rows and 1 column. So its order is 2 by 1. Now, since the order is different, thus the matrix A and B, they are not conformable for addition. A and B are not conformable for addition. That is, we cannot add the two matrices because they have different order. Similarly, if we consider the addition of matrix A and C, then we already know the A is of order 2 by 2 and C is of order 3 by 2. Thus, they are also not conformable for addition. Here the matrix C has order 3 by 2. Here we see that it has 3 rows and 2 columns. So it has order 3 by 2. The matrix A has order 2 by 2. Both have different orders. Thus, these two matrices can also not be added. A and C are not conformable for addition. Now we check whether the matrix A and D can be added or not. Again, we see that the matrix D here, this is the matrix A, the matrix B order, then we have the matrix C order, then D is of order, D is 2 cross 1 matrix. We see that A and D cannot be added, but the order of the matrix B and the order of matrix D are the same. Therefore, B and D are conformable for addition. B and D are conformable for addition because they have the same order. Similarly, we see that the matrix E here, it has also order 2 by 2, 2 rows and 2 columns. E is 2 by 2 matrix. We know that the matrix A is also of order 2 by 2. Thus, A and E are conformable for addition. Now the last matrix, the matrix F, it has order 3 cross 2. That is, we have 3 rows and 2 columns. This is the same entry, 1 plus 1. It will give us 2. Similarly, 3 plus 2, it's a single entry. This is also single entry. So this matrix has 3 rows and 2 columns. F is 3 by 2 a matrix. We see that the matrix C is also of order 3 by 2. Thus F and C are conformable for addition. Thus, if we summarize here, the matrix A is of order. First, we see which matrices are conformable with are conformable for addition with the matrix A. So the matrices conformable for addition with A are the matrix A is of order 2 cross 2. This is 2 cross 1. This is 3 cross 2. This is 2 cross 1. This is 2 cross 2. So the only matrix which is conformable for addition with A is the matrix E. Similarly, the matrices conformable for addition with the matrix B, we see that only the matrix D is conformable for addition with the matrix B, because both matrices have the same order, 2 by 1. So only matrix D is conformable for addition with the matrix B. Then matrices conformable for addition with the matrix C are those matrices whose order is the same as the matrix C. We see that the matrix F has the same order as the matrix C. It has order 3 cross 2 or 3 by 2. Similarly, the matrix F has order 3 by 2. So F is conformable for addition with the matrix C. Next, we solve the second question, in which we have to find the additive inverse of the following matrices. For example, the matrix A is given as 2, 4, minus 2, 1. B is given by 1, 0, minus 1, and so on. Similarly, this is the matrix F. We know that the additive inverse of any matrix A is obtained by, for example, this is the matrix A, then its additive inverse is the negative of A, that is multiplying the matrix A with negative 1. Therefore, for example, if we have A is equal to 2, 4, minus 2, and 1, then its additive inverse will be the matrix obtained after multiplying the matrix A by minus 1 or negative 1. That is, negative A is equal to, every element of the matrix A will be multiplied by negative 1. So positive 2 becomes negative 2. This is positive 4. So it becomes negative 4. Negative into negative becomes positive. And similarly, this becomes negative 1. Thus, this is the additive inverse. It's the additive inverse of the matrix A. Similarly, if you want to find the additive inverse of the matrix B, then we'll multiply the matrix B by a negative 1. Thus, we have B is equal to 1 becomes negative 1. 0 multiplied by negative 1 is 0. Anything multiplied by 0 becomes 0. Then negative 1 into negative 1 becomes positive 1. Negative 1 into 2, we have negative 2, then negative becomes positive. We have positive 1, then negative 3, negative 3, positive 2, and negative 1. In simple words, we'll replace each element of the matrix B by its additive inverse. We know that the additive inverse of 1 is negative 1, 0 is the neutral. Then additive inverse of negative 1 is positive 1, additive inverse of 2 is negative 2, additive inverse of negative 1 is 1, then additive inverse of 3 is negative 3, again the same. Then also the additive inverse of negative 2 is positive 2, and as before, the additive inverse of 1 is negative 1. Similarly, we can also find the additive inverse of the matrix F, which is obtained as multiplying the matrix F by negative 1. 3 square root, so we have negative 3 square root, then the additive inverse of 1 is negative 1, the additive inverse of negative 1 is 1, and similarly the additive inverse of 2 square root is negative 2 square root. So the additive inverse of the matrix A is given by the negative A. Similarly, additive inverse of B is given by negative B, and additive inverse of F is given by negative F. In the next video, I'll solve question 3 and 4 of this exercise, that is of exercise 1.3. Thank you for watching.